My first actual data science job was literally the result of waking up from a dream.
How does that lead you to where you are now?
I had an experience that I think a lot of data scientists have, which is getting sort of inexorably dragged down the stack. What I wanted to do was do all this cool data science that would like make a difference. But what it kept turning out I had to do was make the data better.
Are there any key factors for improving voter turnout?
Turns out that working for political campaigns is like really exhausting because everything is on fire all the time.
It's an interesting data problem.
How do you fund open source software? And there have been a lot of different models to try and fund open source software. And the reality is, unfortunately, that most of them kind of suck.
What do you think the state of the language war is now?
I don't understand why people like put up with Jupyter notebooks. Like, y'all can have nice things too.
This episode of Ken's Nearest Neighbors is powered by Z by HP, HP's high compute, workstation grade line of products and solutions. Today, I had the pleasure of interviewing Alex Gold. So Alex recently published the book DevOps for Data Science. And in this episode, we're going to dive into a little bit of what DevOps is, what it isn't, and how it might be different from MLOps, which we've talked at length about on the podcast. Alex also has had a very interesting career. He's currently the director of solutions engineering at Posit. And we're going to ask some questions about what solution engineering is, who might be a good fit for those types of roles, and what opportunities are available there. We'll also dive into some of the details on the language wars. Obviously, Alex works at Posit, so he has a little bit of a strong take on the R versus Python debate. I really enjoyed this conversation with Alex, and I'm sure you will as well. Alex, welcome to the Ken's Nearest Neighbors podcast. Thank you so much for coming on.
It's great to be here. Thanks for having me.
Of course. So we met through some mutual friends at Posit.
Yeah.
Obviously, I've worked with them a lot. Well, you guys a lot in the past. And you have a book coming out. I wanted to learn a little bit more, one, about your story, and two, a little bit more about the overarching process and your book in general. So I'd love, before we get into all of those wonderful things, I'd love to first start with a little bit of background on yourself.
Yeah.
Maybe let's dive into where you first got interested in data.
Sounds great. Yeah. So my background, my undergrad was in math and econ. I went to Wesleyan University. They don't have minors, at least they didn't at the time. So there was this funny, like, it was not quite a double major, but it was like a major and a minor in math and econ and math, that order. That was one thing. Anyway, maybe it's still there. I don't know if there are Wesleyan people listening. I'd be curious to know if it's still a thing. But so that's what I did. And the thing I thought was really cool about economics, and the reason I like really loved it, is that it was numbers, it was math, but it was about the real world, right? It was not just sort of math for its own sake. It was really, related to things that people care about in their day-to-day lives. And so I spent the first few years of my career working in sort of the economic policy world in Washington, D.C. I worked at a couple different think tanks and found myself, I did some data related stuff, some just like general, qualitative policy work. Found myself enjoying the data part much more. And then a few years down the road, I started an econ PhD program and dropped out. And then a few years later, ended up going sort of all the way into the data world. And, it was really more of the same. It was, right. It was numbers, it was math, it was statistics, but it was about the real world. And that was what was so interesting to me, right? Is I got to do these like sort of, I think a lot of us who love data, right? We love like the puzzle aspect of it. You write the code, you get the data shaped right, and then you make that visualization or you build that model. But I also really like that it was actually related to the real world and not just sort of, math for its own sake.
We had a very similar experience there. I mean, in college, I remember taking my first econ course, and I was honestly a very bad student until that point. And it all just sort of made sense. I realized that I could see the world through trends, through graphs, and I could start to understand it in a very different way. And that was something that really spoke to me. And it opened the door to saying, hey, if this is useful to understand trends in human behavior, can I use it to understand my golf game better? Can I use it to understand all these different things? And I remember how powerful that was. That sort of opened my mind up to the possibilities of math or statistics being an applied thing rather than just a theoretical thing, which was super, super cool.
Yeah, absolutely. And I think what's really interesting about data science as a field is that I think that's the story of a lot of us who are in data science or who got into data science. I mean, these days there are a lot of data science programs, which I think is awesome. Like now you can get a bachelor's or a master's. I don't even know, there may even be doctorate programs in data science per se. But when I was in school, that didn't exist. And so everybody who sort of ended up in data science was coming from somewhere else. And that's something that I think is really cool about this field is just how it sort of is this marriage of a lot of really interesting statistics, machine learning, computer science kind of stuff, and then like what can you do with this in the real world? So yeah, that totally resonates for me.
Amazing. Well, so you talked about how you're doing some of these think tanks, you're working in policy in DC, you're working in and dropped out of your PhD program. How does that lead you to where you are now?
Yeah. So there's another hop after that. So my sort of policy world led me into data science, and my first data science job was a political job, doing work on political campaigns. So that was sort of like a little hop into data science. Then I had another role after that in data science, more like generic data science. I was working for a big consulting firm. Did some work with hospital systems, did some work with the Social Security Administration. And that was, sort of general data science. I ended up leading a team in that role. And then from there, I had obviously been spending a lot of time using R, getting excited about the power of programming for data science, right? Not just the model building or the dashboarding or the visualizations. But I had an experience that I think a lot of data scientists have, which is getting sort of inexorably dragged down the stack. That like what I wanted to do was do all this cool data science that would like make a difference, but what it kept turning out I had to do was like make the data better, right? And then eventually you end up like managing a database. And at some point I found myself managing an RStudio server because like somebody needed to do it. And so what I found was I actually kind of enjoyed that part of it, right? I enjoyed learning about how to like administer a Linux server. I enjoyed learning about how sort of database administration worked, although I learned like this much about that topic. Then what happened, honestly, is I got connected to some folks at then RStudio, now Posit, and learned a little bit about solutions engineering, and made the hop over to then RStudio about 5.5 years ago. And so spent about a year and a half being a solutions engineer, and happy to talk more about sort of what that means, right? But it's sort of this interesting spot about helping our Posit customers have a great time using the Posit product, right? How do you make sure that the environments that data scientists have to work in are great environments to do data science? And so really enjoyed that. And then, I'd been a manager. I really enjoyed being a manager. And when managerial roles opened up, I moved back into management, and have sort of taken on successively bigger management roles. And so now at Posit, I lead the solutions engineering and the technical support teams, which is really, really a blast. So yeah, it's one of those stories that I remember, when I was 23, 24 in my first job, somebody telling me that like careers make no sense lived forward, but the story makes a lot of sense told backwards. And I really feel like saying this out loud, that really resonates for me, that like, oh, that story makes a lot of sense when I tell it this way. But at the time, it made no sense whatsoever. I'll just share like my first actual data science job was literally the result of waking up from a dream that I had. I like woke up, I'd had a dream that I was going to work for it was 2015, fall of 2015. I was like, oh, I'm going to go. I had a dream that I was working for the Hillary campaign. I was like, okay, I'm going to go do political data science stuff. And that was just it was a great left turn, but it was a total left turn for my career. And it was literally the result of a random dream that I had. I just like woke up and I was like, oh, what if I actually did that?
That's fascinating. And, the more people I talk to on the podcast, the more that really hits home, including in my life. I mean, nothing really makes sense until afterwards when you look back at it and you put it all together. And going through it, we're all kind of just fumbling through the dark and trying to figure it all out. Before I dive into the solutions engineering stuff, I'd love to learn more about what you were doing in policy and those types of things. I think that it is election season right now, and I don't particularly want to get into any politics, but I'm interested in the data surrounding the politics and like what goes into those types of things that maybe the layman isn't familiar with.
Yeah. So I worked in both policy and politics, which from like, if you're outside of it, you're like, those are the same thing, right? But like fundamentally, they are quite different, right? Policy is about what is the government going to do for people or not do, right? And then politics is about who wins elections. And so while they are related, obviously you only get to do policy if you win elections, if you're on one side or the other. The sort of practice of it is completely different. So as in the policy world, I did some data work, for example, where we were using some longitudinal surveys of basically the economic success achieved by children. And so we were trying to do this like very complex modeling. If anybody's familiar with the National Longitudinal Survey of Youth, the NLSY surveys, these are what we used. And we built this model that could, at least in theory, we created this synthetic data set of people from age 0 to 40. Now, there's no actual data set that follows people from 0 to 40. And so we took these several different data sets and stitched them together with a variety of different sort of like statistical matching techniques and other kinds of inference techniques. For what it's worth, I did this all in Stata, which was a real If I know there are people out there who think like R is a difficult language to work with, you should go have some fun with Stata. That's a bear. So that was what I did on the policy side. So that was really, really interesting. They're interesting statistical problems. For the most part, a lot of data on the policy side is smallish data problems, right? They're longitudinal surveys, which are very expensive to collect. Occasionally, you do get larger data sets, like in some later stuff I worked with hospital claim data, which is not huge, but it's large, right? You have like one line of data per every single procedure that happens in a hospital. So you have millions of rows. You're still in sort of modest sized data there. In politics, there are a variety of different sources of data. One of the biggest ones is something called the voter file, which people who are not in the political world might be sort of horrified to know exists, but it's a standard thing. Each Secretary of State for every state keeps a voter file, which is a list of all the people who are registered voters in that state, and when they have voted. So like as we like to say to people, who you vote for is private, but whether you voted is a matter of public record. And so a lot of data, there's a lot of work in politics done off of these voter files. My understanding is that like also a lot of commercial data stuff like starts at the voter file in a lot of cases. And so these data files are compiled by state secretaries of state. There are then companies that go around and gather the data from all 50 states, because actually it's like a pain in the ass to homogenize 50 different state voter files. And so we were doing a lot of work. The role I was in, we were doing voter outreach experiments. And so we were looking at things like, does this message or that message make people more likely to go out to vote? And so the kind of things we would do is before the election, we would take the voter file, we would randomize it. And like some people would get this piece of mail, some people would get that piece of mail, some people would get nothing or this text or that text. And then after the election, we would gather back up the voter files and see who voted and who didn't. And so they were literal like field experiments on voter outreach. This is sort of the gold standard, obviously, because it's an actual randomized controlled trial. But there's just a ton of data stuff going on in politics these days.
Oh, that's fascinating. That makes a ton of sense to me. You think about a lot of the campaigns that are run about getting people to vote rather than, I would imagine it's a lot easier to get someone to vote from who's aligned with a specific party than to convert someone to vote for a different candidate. And it's an interesting data problem of, hey, let's invest money in just finding people and getting them to vote versus trying to change opinion, which is maybe a little bit sad. I think like the idea of having a message that you believe is important and like winning people over with that is important. But if we think about like effectiveness, there's another side to that as well.
It's a great point. And like when you're thinking about what if you're aligned, right? Like the organization I worked for was aligned firmly with progressive causes and candidates. And so like, if that's the side you're on, right, what you're trying to do is you are trying to increase the vote margin for progressive candidates. And there are basically like three things you could do. You can make people who were going to vote for a Republican vote for a Democrat instead. You can make more Democrats or people who are going to vote for Democrats, at least, because very few people actually register these days. They say they're independents, but almost nobody's actually independent. And so you take people who are going to vote Democratic and you get them to come out, or you get the Republicans to stay home, right? Those are the three things you can do. The third one of those is a little distasteful, I think. Like, you know, it's sort of some dark side stuff there. But those are kind of the three options you have, and there is a really active, I think, debate honestly going on about whether persuasion, which is getting people to go to the other side, or straight turnout stuff is more useful. It definitely varies election by election. The other thing that's really interesting is obviously you can do a lot more in a smaller election, right? So like if you're talking about in 2015, 2016, obviously it was Hillary Trump was the election. And like most people knew a lot about that election. And there really is only so much you can do to affect that. You know, they're on the news constantly. There's a ton of earned media. And so any paid, any new, right? Like, do you actually think one mailer is going to change people's minds on whether they're going to go vote for Hillary or Trump? Like, probably not. But when you're talking about down ballot races, when you're talking about a state Senate race or the district attorney in Chicago, those are races actually where this kind of paid media can have a much bigger effect because people aren't paying as close attention. Their minds aren't made up ahead of time. They're more persuadable, and they might not be planning to vote at all unless they learn something about the candidates or are, sort of incentivized to come out for it.
This episode of Kansas Nearest Neighbors is brought to you by Z by HP, HP's high compute, workstation-grade line of products and solutions. Z is specifically made for high-performance data science solutions, and I personally use the ZBook Studio and the Z8 workstation. I really love that the Z workstations can come standard with Linux or WSL2, and they can be configured with the Data Science Software Stack Manager. With the Software Stack Manager, you can get right to the work of doing data science on day one without the overhead of having to completely reconfigure your new machine. Now back to our show. So this might be an impossible to answer question, and it might be highly variable depending where you are, markets, whatever it is. But are there any key factors for improving voter turnout that are just like hugely correlated with improving I'm interested to know maybe what some of the notes.
Yeah. So one of there is this line of research called social pressure, which basically is like we as humans are very susceptible to what other people are doing. And so, and again, I kind of got out of this world in 2016. So this was the state of the art in like 2016, which is now quite old. But at least at that point, people, this had sort of been fully internalized, but like everybody was using these sort of social pressure techniques, which basically are like 3 out of 4 of your neighbors voted in this last election. Are you going to vote in this election? And it's sort of this sense that like everybody is voting. It is your civic duty. You should go out and vote. And that at least among any of the sort of get out and vote messages that people tried, that one is a real winner. Showing people's like showing your voter record versus your neighbors, and like your neighbors are more consistent voters. You should probably get out there and vote. People respond pretty strongly to that one.
That's very cool, and that's honestly like probably a more ethical one.
Yeah, that seems pretty good to me, right? Like, yeah, you should go out and vote. Even as somebody who has pretty strong preferences about who people vote for, like you should go out and vote. It's a good thing. It's part of your civic duty. And voting rates in this country are depressingly low. Turnout even in big elections is 60-70%.
Are they trending a specific direction, or are they?
I'm not aware of that. honestly, I was very enmeshed in this through, the winter of 2016, and then kind of decided that was a great period of my career. I learned a ton about data science. It turns out that working for political campaigns is like really exhausting because everything is on fire all the time. And I was very happy to move on from. I'm really glad I did it, but I was also very happy to like move on out of that world. Also, the reality for me, at least, is that I enjoyed the work. I personally did not. Some people get really like they just want to win elections and like getting out of bed to win an election like that. That wasn't me. I really enjoyed the data science of it. I thought that was really fascinating. But ultimately, although I care a lot who wins, I did not find that the work of being, trying to win elections was work that I found compelling enough to overcome the fact that it was a pretty grueling pace, especially in cycle.
Well, that makes a lot of sense to me. I can imagine how I guess fast that moves, especially with like very specific and strict deadlines for when things happen.
Yeah.
I think that is a really good segue to compare maybe your data science work to what a solutions engineer does.
Yeah.
Because I think it's most people are very familiar with what data work is. I mean, you painted quite a cool story about what your data work used to be. How does that differ from maybe a traditional solutions engineer role?
Yeah. So, I mean, it's interesting, right? When I came to RStudio, then Posit, right? For people who are in the R community, I think it's easy to imagine, at least at the time, I think this is maybe less true than it was back then. But like at the time, it was like easy to imagine that all of RStudio was just like Hadley and JJ and like Winston and Joe hanging out and like writing open source packages. And like that was what RStudio was, right? It was like the RStudio IDE and Shiny, and like that was kind of what we did. And then I started working there, right? It's a software company, right? We are a software company. We are, I think, somewhat, we have a little bit of a unique take in that we're a public benefit corporation. We're really genuinely committed to furthering the creation of open source software and furthering open source data science. So it's a really cool company to work for. But at the end of the day, we are a software company. We have to do all the things that a software company does because I think underlying the way Posit works is this question of how do you fund open source software? And there have been a lot of different models to try and fund open source software. And the reality is, unfortunately, that most of them kind of suck. Like, you can get out there and you can do grants. You can try and find a funder. You can do like freemium stuff. You can do services on top of open source software. And some of those work and can be sustainable. A lot of them are just not that sustainable. And so the model that Posit has adopted, right, is we have many engineers working on free and open source stuff that we provide to the community, which is really cool. But then we need to pay for that. And so what we do is we have, right, professional products that we believe provide value over and above the open source software. And in particular, the way we think about it at Posit is, we really give away all the stuff that an individual data scientist needs to be successful on their own. Where we charge for software is the things that teams and organizations need to adopt and succeed with open source at scale. And the reason for that is like, if you're an individual person, if you're a student, if you're a hobbyist, just doing something, like you should just be able to do that, right? But if you're fundamentally achieving organizational value on open source software, right, that's where we say, hey, like we're contributing a lot to this. We want there to be a fair exchange of value here. And obviously, companies do get really far just using our open source stuff. That's awesome. A lot of organizations want a higher degree of security and stability. And honestly, they want somebody to yell at when it all breaks. And so that's what we provide with our professional products. And that's sort of the solution engineering role is this really cool role where we work with Posit prospect, people who are considering our professional products or have purchased them. And we help them figure out how do the Posit products fit in to the ecosystem of other data things they are doing, right? These days, nobody has one data product. And so we help them understand, where does Posit fit into the stack that they already have? And then we help them implement it, right? We help them figure out, how do I make authentication work so the right people have access, and the right people have access to the right data, at the right time? How do we, configure the system so that it's stable and doesn't like fall over when 100 users come on to use Posit Workbench or come on to look at a shiny app. And so that's where the solutions engineering role is. This really cool. It's a very technical role, but also like you work with people all day, every day, and I think it's a really cool role for people who really enjoy technical stuff, but also enjoy working with people, enjoy talking to people, enjoy explaining things to people. So that was sort of a meandering path to get there. But I want to set some context around, like, what does a solutions engineer do? Because it's a foreign role to a data scientist, because it's really a role that comes out of being a software company, not out of doing data science.
Yeah. I mean, so where would you characterize where would the sales engineering role fall between like a data scientist, or maybe like a client facing data scientist, and like a salesperson?
Yeah, great question. It's somewhere in between for sure. I would say it really depends on the role, right? We have people who are doing more engagement with our sales team, and those people are closer to sales, right? Most of what they are doing is they're putting together demos, they're putting together proof of concepts, they're helping organizations try the Posit software and figure out if it works for them. So it's still a very technical role, but ultimately the job is to help that company figure out, like, yes, Posit is the right choice for me. I'm going to pay you for this software. Then there are folks who are more on the post sales side, and that is more of a enhancing adoption, making sure that the platform is really great. And so on the team, it's about 70-30, 60-40 between people who have a data science background and people who have like an IT administration background. Because to do this job well, you really need both parts. You need the data science to be able to understand what customers are trying to do with our product. So when they say like, yeah, I'm trying to deploy this model and like I want to like have it run when this Quarto doc runs and like push it out to this system, like you have to understand what all of that means. But a lot of the day-to-day work is really around, how do I get the system stable? How do I get the system up and running? How does the Linux server need to work? How does the file server need to work? And so the day-to-day work is not a ton of data science, but a lot of us on the team have this background in data science because it's what we're talking about all day, every day. We're helping data scientists articulate to the IT admins, hey, here's why we need to set this up in this way, because like that's how I'm able to do my work. And then we talk to the IT admins to help them translate with the data science folks, and sort of play this role of a little bit of translation. Sometimes there's a little bit of therapy in there too, depending on the organization.
Yeah, I mean, surprisingly, it sounds to me very similar to like a consulting role.
It's not dissimilar, yeah.
Where you're kind of straddling, you're like getting the solution and you're helping to facilitate things. I'm not necessarily seeing things all the way through. Like the company asked to take this somewhere, but like, hey, like let's get you into the right place and continue. I mean, one of my early roles was fairly similar to that. So I came from management consulting into data science, and that was like a transition point to me where I was doing technical things. I had finished my master's in computer science at that time, but I was coming from a more traditional consulting side, and it's like, well, honestly, this is probably easier. It leverages more of my skills than necessarily just going straight into data science. And then obviously eventually did make that transition, but I really relish that type of work. It helped me understand.
Yeah, I think for the kind of person who enjoys that, right, like consultative kind of work, I think this is a really awesome job. So I love it. I think it's a really, really cool position to be in. The other thing that I think is really cool about the way we do it at Posit, at least, is that the solutions engineering role we're not just customer facing, right? We also, because we are in this unique position of being very technical, very knowledgeable about the products, very knowledgeable about data science. And we're spending all this time with customers. We just know a lot about what customers are trying to do, what they need, what their pain is. And so we really think a lot about the responsibility to like take that and help other people at Posit, right? Bring that back into the products, bring that back into our documentation, bring that back to the open source engineers and the professional product engineers, so that ultimately, right, what we learn doesn't get stuck in our heads and doesn't become sort of like, oh, we're going to fix it for this customer, but can over time, make it better, make the docs, make the products better for everyone.
That's such a cool feedback loop. I don't think a lot of people really think about that as much.
Yeah,
which
that to me is the like, that's the part of the job that I think is like makes it from like, oh yeah, that's a cool job, to like, oh, that when I'm talking to people who are in the interview process, like I sort of say to them, I'm like, this is a big job. Like, people who succeed at Posit in this role are excited about having a big job with a lot of freedom, where they just have the ability that they are asked to go try and improve the products based on what they've learned from talking to customers. I think people who thrive in the role find that exciting. I think everybody finds it terrifying when they start. I certainly did. But people who thrive in the role find it both terrifying but also invigorating and not paralyzing.
Well, I think so. I've talked to JJ. I forget what episode number it was, but it seems like part of that is also a transition to doing more Python stuff. Yeah. I mean, obviously, very common language in the data community. Some of my basketball clients are using R, and it's interesting to me because I'm like, pretty like aggressively Python guy. But I'm wondering, obviously you're in a unique position going from RStudio to now having Shiny for Python and having some of these other options. What do you think the state of the language war is now?
Yeah, I really think that we are in a spot where what language you choose to use, and I mean, between Python and R, right? Like, if you want to go write some C++, like you're doing a different thing entirely. But between Python and R, I really feel at this point like a lot of it is style and background. Like, I think personally, I really love R. That's the background I come from, right? I come from a social science background. I did 2 semesters of computer science in college, but like, I'm not a computer scientist. And so like, for me, R makes a lot of sense in the way it treats data. I really like the interface. I think the tidyverse is awesome. I grew up using RStudio and learned a lot there. And so like, that's great. I think there are some libraries in Python that are better. There's some libraries in R that are better. These days, I think that's that's why you would choose one or the other, or you're on a team that has standardized on one or the other. The degree of interoperability, especially like if you look at like Quarto for creating interactive documents, you can go like one code chunk to the next, different languages, fine, no problem, right? You look at like the ability of in either R or Python to write an API to speak to the other one or like to something else entirely, fine, no problem. I think recently, right, we released, is it now beta? The Positron IDE, which is a new IDE that sort of is growing off of what JJ and folks learned about building RStudio and creating a from the ground up multilingual data science thing. And honestly, for me, and I know Python people feel differently. For me, the main reason I didn't want to do Python is like, I don't understand why people like put up with Jupyter notebooks. Like, y'all can have nice things too. I don't know. Like, I just think the RStudio IDE is so great. I've always loved it. And maybe that's because I come from there, but I always struggled to get into doing my work in a Jupyter notebook. It just like never really worked for me.
It's funny you say that because I've never like actively used Jupyter.
So what do you use?
So when I started writing in Python, I actually use Anaconda, which is like very, very similar to RStudio.
Sure.
And then people made fun of me for that. So I started using VS Code.
All right.
And I use VS Code now. And I think VS Code, you have to install a lot of plugins to get the environment right. Yeah. But the funny thing is my VS Code setup runs very similar to how my Anaconda environment was.
Yeah, or like
my
have you tried Positron
no,
yet?
It wasn't Anaconda. It was Spider, not Anaconda. Yeah. Sorry. Spider is very similar.
Yes, it is. I tried Spider and I was like, oh, this is cool, but it is not as baked as our studio was at the time. Have you tried Positron yet?
I haven't yet.
Okay, cool. So
I'll
it
give
is
a try.
fundamentally a like it's a VS Code. I don't know if I don't know if it's a fork or how exactly you would describe its relationship to VS Code. But it for people who are comfortable in VS Code, it really like pulls downstream of that, but builds off of the idea of a 4-pane data science IDE, which like same as Spider or our studio, but sort of modernized and based off of VS Code, which for the folks, this is not my area of expertise, but like gave us a lot of things out of the box that in our studio we had to build ourselves, right? Like things like as a very simple example, like coloring of code lines and that sort of thing, right? Is like the kind of thing like you just get from open source VS Code. So if you haven't tried it, you might want to.
Yeah, it's where honestly the one thing I miss the most is being able to see all of the data frames that you have like in working memory, and that was 100% like the single largest factor why Spider was very appealing to me. And now I operate without it, but I feel like
you've like learned to live without it. Yeah. So anyway, I mean, that was so to go back to your original question, like, to me, it's just like, it's more, and the other thing I didn't mention, right, is obviously like Arrow and other, storage formats that allow basically symmetric access from R and Python. And so you can just like save in Parquet or whatever. And like, it's fine, right? Like you get actually nice, right? It's not like saving in CSV where like then you import and everything kind of, you got to like recast all your dates and stuff, but like it like actually works. And so I think like increasingly it's an interface level. The language is an interface level. And like, I think that's going to become even more true as LLMs become more and more capable in this regard, that it really is going to come down to some combination of personal preference and like, there's this or that package that happens to work better, right? Like, I don't know, at least as of a couple, I have not kept up with like natural language processing very much, but like as of a couple of years ago, right? The what is NLTK in Python was like a better natural language processing library than anything I thought there was in R. And so like, if you were doing that, I'd be like, yeah, go use Python. I think that's the kind of thing where it's going to come down to is there are going to be sort of esoteric packages for doing this particular task or that particular task that might be better in R or Python. But other than that, I think it's really going to come down to what interface do you like better?
I think I 100% agree with that sentiment. I mean, for example, I remember doing PCA in R was just so much better than in Python. Granted, not really a tool I use very often, but I was willing to like basically relearn R every time I had to do PCA just because I didn't like using the Python libraries that were there.
Yeah.
And, just as you said, I think a lot of the AI tools we have now democratize the process or like the analysis to whatever language operates.
Yeah. I'm actually a little, and I'm curious what you think and what you've seen about this, but I'm actually a little concerned on that front because the way these LLMs work, right? They are good at a lot of basic tasks. And I feel like you still need an expert to look at it and make sure it's doing what you think it's doing. And I do wonder if like it introduces this at least question of like, how do junior people get their start if you're able to do a lot of the stuff that a junior data scientist would do? If an LLM can kind of do that, how do you get over that hump to like being able to then review what the LLM wrote and really knowing like, yep, what it wrote, like that was what I meant, or like, oh shoot, that was not really what I meant. Like try again, Claude. That feels like an unsolved problem to me of like, it's cool that it can do some of these different kind of tasks, but it still feels to me like there's a need for expert eyes on it to make sure it's doing what you want. And I'm not sure how you get that exposure in a world where like LLMs are, not today, but like in 5 years kind of territory.
So I think as they are right now, agree 100%. Basically, we need a lot of the stuff it produces is wrong or it doesn't work, or it's like I had an issue where I was writing some code and when I ran it on my machine, I just got different results.
Oh,
And I was
jeez.
like, why is this happening? Basically, a name was misspelled, and I was like, okay, fine. Like,
Yeah,
but I'm a little less concerned because I think that it allows people to iterate faster and see dramatically more code,
sure.
and that evens out it evens out that eventually, because there are going to be bugs in the code. You're going to be getting bad results, and like, frankly, you're not going to have a job if you're producing bad results, or
Totally.
you're there is a compromise. And so inevitably, I think sort of the market corrects itself that,
Interesting.
hey, after you make a couple mistakes, you start scrutinizing it really carefully, and then you can actually use it as a tool for debugging itself, in the sense that, like, hey, like, why is it this way? Why did you choose that rather than this decision? Are there other ways to do this?
Yeah,
I think
that's
it,
cool.
I believe a lot of those problems can be solved with good prompting. And by good prompting, I mean asking questions of what is being built and
Sure.
having it break itself down.
That's interesting.
That's also a skill I think that has to be cultivated. So it's not something that comes out of the gate. But that's, I'm, especially with people who are learning, I think they will give up before they come over reliant on it, because they'll have problems with what's being created as well. So that's sort of where I fall. But I think it's still a completely legitimate concern.
Yeah, it's interesting. That makes a lot of sense to me. I think one of the things I'm concerned about, and we got like we're like 40 minutes in. This is the first time I'm mentioning my book, DevOps for Data Science. But like in the book, right, one of the things that I talk about is that like if you're doing regular software engineering, there's basically like one kind of correctness you care about. It's basically like, does it run in a performant enough way? Like if your software does that and you're doing sort of general purpose software engineering, like it's fine, right? Like Zoom needs to run, and like when it runs, then like Zoom Excel works, right? But like when you're talking about data science, there's this second sense in which it needs to work, which is like the answers need to be correct, and they need to be what you meant them to be, right? And like the problem with that is that unlike the way you can write unit tests for a software stack, it's very difficult to write testing for actual results in data science, because usually like you wouldn't be doing it if you knew what the answer was, and you could just run it and make sure you got the right answer. And so I think like what you're saying makes a lot of sense to me. It is still scary to me that probably you're going to find out those mistakes by like putting them in front of somebody who is an expert, and they'll be like, this number makes, I mean, we've all been, right? Like this number makes no sense. We've all heard that. It's like, oh, geez, what have I done? But but there's a second level of correctness that you care about in data science that isn't there in pure software engineering, that I think makes that sort of self-correcting piece a little scarier, I think, for a data scientist. Whereas like if you're just writing code, if it doesn't run, it doesn't run. Or if it like takes too long, it takes too long. But like, in data science, like your data merge can work in some sense of the word, but completely screw up your data along the way. And you may not realize that for a long time, which is terrifying.
There's not like binary outcomes,
right? Yeah,
where it's like yes or no. It's this is sort of right,
yeah,
or this is sort of wrong,
yeah.
or
you can kind of code can run and give you completely the wrong answer, or like do something you don't intend, right? Like there was that whole thing a few years ago in scikit-learn, like the default for a lasso regression made it actually do you remember this? Like it was that like the default value for some type of regression was not what people thought it was, right? It was like this very, like, it's like an interesting thing of just like, oh, if you're not reading the docs super carefully, you actually didn't do the kind of regression you thought you were doing. And that's bad, right? Like you want to do the thing you thought you were doing and you meant to do.
Okay, that makes sense. Where it's like, I would assume it's like a lasso and a ridge.
Yeah, it was like the penalty on a lasso was something. Somebody's gonna like yell at me that I got this wrong, but it was like the penalty value wasn't what people thought it was by default or something. Like it was something like that people were surprised to be like, oh, I read the docs and it is different than I thought it was.
Interesting. Well, I think that's Unfortunately, I think we're probably going to see just more issues like that presenting itself. I think we're going to see a lot of people who are starting in this field like learning those lessons. The idea is that hopefully they learn those lessons in school now,
Right.
Rather than in the workforce, and that is where they can cultivate that. You know that.
Although I don't want to speak
approach.
for you, I certainly learned those lessons the hard way, and so like I can't say that anybody learning those lessons the hard way, like with an LLM involved, like probably that makes it better, not worse. But you know, like I didn't do any better as a human. I learned those lessons the hard way personally.
Yeah, totally fair, but you know, I think that I wonder if the error rate associated with that will go up or down.
Yeah, it's an interesting question.
Maybe it could stay the same.
Yeah,
I mean that's something maybe we'll talk again in 5 years and
right.
be able to remiss and
I look forward to it.
Yeah. So you know, talking about the book, talking about the nature of, I guess, like DevOps in the data science space. Can you explain maybe what that actually means and how that might be different from, for example, MLOps, which is talked about quite a bit?
Yeah. So, you know, fundamentally, DevOps is a set of practices, procedures, and tools, sort of, right? So here's like I'm gonna digress here and tell a little history, right? So you're like in the 90s, and right, at least according to these stories, which I believe are completely apocryphal, everybody is writing their software using the waterfall method, where you like spend a year gathering requirements, you spend 2 years writing software, and then voila, it doesn't do what you thought, right? Like that's the like waterfall story. I'm somewhat doubtful that ever actually happened, but like that's the story. And so then comes the rise of Agile, right? The Agile software movement, which is like this idea that you're gonna, instead of trying to like do a year of requirements gathering and 2 years of building, you're going to build small increments, you're going to deliver quickly. And like fundamentally, while Agile is a development method, it's also a method of like checking that you're doing the right thing, right? Because you're frequently going back to your customer, whether that's a customer, an internal customer, and you're saying like, does this do what you want it to do? Is this the right thing? Is this the right thing? But there's a problem, which is you can write the code that does, you know, creates this thing, but like, how do you then deliver it? Right? You have to put it into production somehow to get it in front of those people. And if you're doing this, right, before you did that like once, right? It was like you spent a year gathering requirements, 2 years building, and then 6 months putting it into production, but it was like one time. But now, you know, like if you're talking about a major code base like Facebook, right? Like they push, I think like it's thousands of updates a week to their code base, and they go live on the site. Like they're constantly just pushing updates. And so a system that requires, you know, 6 months to check that a release is good to go, just, I mean, that's not going to work if you're trying to release, you know, even if it's once a month, right? Which is a slow release cadence for a lot of products. Like that's completely untenable if it takes too long to get into production. So DevOps is this system of tools, procedures, processes, so that you can build the software to make it easy to put into production, and put things into production in a way that they're going to be safe, secure, observable. You can see what they're doing. You can understand what happens when they go wrong, recreate the error, and try and fix it on the code side. And so it's basically trying to bring closer together the development, the dev, and the day-to-day running of the software, the ops, right? And so that's where it comes from. It's a sort of pure software engineering kind of concept. And so, you know, as might not be surprising given how I described what the solutions engineer role is, like that's what I spend my time discussing with our customers. Like, how do you take data science and put it into production? How do you make it production grade? How do you like write code that is ready for production? And then how do you actually put it into production? And a lot of that is lessons from DevOps, or they're an interpretation of DevOps. And, you know, it's tempting, I think, for people who are software engineers to be like, you just do DevOps, but you should just do it in R or Python. And I think that's really wrong. Like, I think fundamentally data science is a different thing than software engineering. Like the analogy I draw is like, if software engineering is like architecture, data science is like archaeology. Like you're doing something in both cases, but they're very different. And the way you think about building software, and if you're doing data science, like you're building software, even if you don't like it or if you're bad at it, like you're building software. And so that's really what the book was a reaction to, was observing that people knew a lot about data science, about machine learning, about statistics, about sort of like graphical design and these sorts of things. But then they got really stumped when it came time to put it actually into production. And so the book is sort of split into 3 parts, where the first part is really about like, how do you write your code, your R Python code, in a way that makes it easy to put it into production when the time comes? How do you think ahead to like, how do I put it into production eventually? How do I make it secure? How do I make it stable? How do I make sure it scales on bigger data sets and these sorts of things? The second section of the book is the part that I really didn't want to write, but I kind of felt like I had to, which is like, if you have to manage the server that's hosting all this, like how do you do that? How do you manage a server? How do you manage a database? What the hell is up with Docker? Like, those kind of questions, which I think a lot of us end up facing. I think most data scientists at some point in their career have to answer these questions, but are really lost about where to start. So that's sort of the middle section of the book. And then the last section of the book is about, okay, you're working at a big company that has an IT admin organization. It's a sophisticated IT admin organization. What concerns are they going to have about the work you're doing? And how do you communicate with them about the work that you need to do, and make sure that they understand what you need from them, and giving them what they need from you, so that you can create a great environment to do data science.
I love that. So let's. I also think that's a very important gap.
Yes.
That is filled. So my hypothesis, and correct me if I'm wrong, so DevOps for data science, it probably encompasses more of the pipeline than just MLOps.
That's right. You did ask about that. So to me, I mean, MLOps is such an interest. Like, to me, MLOps is just this like, and I don't know, there's been so much hype around it, but like, it's this tiny narrow slice of the pie, which is like, once you've built a machine learning model, how do you serve that machine learning model? And then how do you, do things like horse racing them? And I'm being a little like glib about it, but to me, it's such a small part of the work you need to do as a data scientist. And at least in my observation, there are organizations that have sophisticated MLOps needs, but they're much rarer than organizations that like have a dashboard in R, or some sort of image processing pipeline in Python, and they need to somehow productionize that. And maybe there's a machine learning model somewhere in there, but there's like a whole data management pipeline on one end. There's a whole downstream pipeline of people or systems who need to consume these things. And so there's a lot of understanding around the narrow slice that I think of as MLOps, which is really about like building and serving machine learning models, which, I think is an important but narrow part of the job of a data scientist. I mean, unless, if you work at Netflix, right? Like, there are just straight ML engineers at Netflix, and that's awesome if you can get that job. But like, most data scientists are doing a lot more than just building machine learning models. And particularly if you want to deliver value, there's so many other things you have to do than just building and serving machine learning models.
Yeah, I get it. So what, in terms of the DevOps for data science, what do you think is the most overlooked aspect of that process?
Yeah, I mean, this is the like unsexy answer, but to me, it's the people. It's that fundamentally what you're doing is you are a person who is working with other people to try and do something that is valuable to your organization or to the world. And so, there are tools, there are systems, but fundamentally what you're trying to do is to work with other people to get something, hopefully something cool, done. And so to me, and I see this particularly from junior folks, right? When my first job managing a data science team, I was working with some folks who were just a couple years out of college, and they would be doing a lot of different kinds of work, and they'd be like, when do we get to do the data science? Like, when do we get to build the models? And I'd be like, well, if what we want to do is provide value to our organization, and ultimately that's what matters, we have to be focused on understanding what is valuable to the organization, what is valuable to the people in the organization. And then there's a lot of like relationship building to get that done. And so, that's why my favorite section of the book by far is the third section of the book, which does not have any code in it. It's all just like helping people understand what it is that IT admins are concerned when they're talking about security. Like, what do they care about? When they're talking about authentication, what do they care about? When they're talking about stability, what do they actually care about? Because to me, that's when data scientists can have the best outcomes, is when the data scientists are able to do data science and when they can communicate effectively with other people who are concerned about all these sort of production-y things and not having to sort of cross wires. But you need to be able to communicate with each other and you need to understand what those people care about, like what keeps them up at night. It's probably not, did you add that extra feature to your model? That's probably not the thing that keeps them up at night. Although it might be what keeps you up at night as a data scientist, and communicating about that, I think is the easiest part to overlook, because it's right. Like, people they're technical people. We want technical solutions. We like the elegance of, APIs fitting together like puzzle pieces, and but then you have to like go talk to the person who's going to like put the API into your production system. And that's a people problem. And that's always going to be mushier than just writing a bunch of code.
I like that answer. It's a little harder to write or research or talk about the mushier side of things. And I'm excited that your book connects those two so elegantly. I'm excited to read the book. Where can people learn more about it? Where can people learn more about and hear more from you?
Yeah. So the entire book is available for free online, do4ds.com, do4ds.com. Entire thing is available for free. There, you can also buy print or EPUB versions on Amazon or wherever you buy books. So if you want a print copy or an EPUB version, you can do that. I occasionally blog at alexkgold.space. I've written a bunch there about management, if that's something that you care about. I wrote about why I dropped out of a PhD program. If you're thinking about that, that's on my personal blog. And then, if you want to reach out and chat with me, it used to be Twitter, but I don't think that's true anymore. I think it's probably LinkedIn. I'm Alex K Gold on LinkedIn. So happy.
Amazing. I will link all of those in the description and in the show notes as well. Alex, thank you so much. Is there anything I should have asked that I didn't?
No, this was great. This was a blast. Thanks so much for having me, Ken, and really enjoyed the time. Thank you.
Amazing. Thank you so much for coming on.
Yeah.